In this section of the course, we'll be going over how to create an isolated test environment using the concept of test doubles. In this lecture, I'm going to go over how you can make sure you're running your unit tests in isolation using the concepts of test doubles. We'll review different types of test doubles such as dummies, fakes, stubs, spies, and mocks. So what are test doubles? Almost all code that gets implemented will depend on another piece of code in the system. Those other pieces of code are oftentimes trying to do things or communicate with things that are not available in the unit testing environment, or are so slow that they would make our unit tests extremely slow. For example, if your code queries a third-party REST API on the internet, and that server is down for any reason, then you can't run your tests. Test doubles are the answer to that problem. They are objects created in the test to replace the real production system collaborators. There are many types of test doubles. Dummy objects are the simplest. They are simply placeholders that are intended to be passed around but not actually called or used in any real way. They will often generate exceptions if they are called. Fake objects have a different and usually simplified implementation from the production collaborator that make them usable in the test code but not suitable for production. Stubs provide implementations that do expect to be called but respond with basic canned responses. Spies provide implementations that record the values that are passed into them. The test can then use those recorded values for validating the code under test. Mock objects are the most sophisticated of all the test doubles. They have pre-programmed expectations about the ordering of calls, the number of times functions will be called, and the values that will be passed in. Mock objects will generate their own exceptions when these pre-programmed expectations are not met. Mock frameworks are libraries that provide easy-to-use APIs for automatically creating any of these types of test doubles at runtime. They provide easy APIs for specifying the mocking expectations in your unit tests. They can be much more efficient than implementing your own custom mock objects, as creating your own custom mock objects can be time-consuming, tedious, and error-prone. Unittest.mock is a mocking framework for Python. It's built into the standard unit test library for Python version 3.3 and newer. For older versions of Python, a backported version of the library is available on PyPy called mock and can be installed with the command pip install mock. Unittest.mock provides the mock class, which is an extremely powerful class that can be used to create test objects that can be used as fakes, stubs, spies, or true mocks for other classes or functions. The mock class has many initialization parameters for specifying how the object should behave, such as what interface it should mock, if it should call another function when it is called, or what value it should return. Once a mock object has been used, it has many built-in functions for verifying how it was used, such as how many times it was called and with what parameters. Mock provides many initialization parameters which can be used to control the mock object's behavior. The spec parameter specifies the interface that the mock object is implementing. If any attributes of the mock object are called which are not in that interface, then the mock will automatically generate an attribute error exception. The side effect parameter specifies a function that should be called when the mock is called. This can be useful for more complicated test logic that returns different values depending on input parameters or generates exceptions. The return value parameter specifies the value that should be returned when the mock object is called. If the side effect parameter is set, its return value is used instead. Mock provides many built-in functions for verifying how the mock was called, including the following assert functions. The assert called function will pass if the mock was ever called with any parameters. The assert called once function will pass if the mock was called exactly once. The assert called with function will pass if the mock was last called with the specified parameters. The assert called once with function will pass if the mock was called exactly once with the specified parameters. The assert any call function will pass if the mock was ever called with the specified parameters. And the assert not called function will pass if the mock was never called. Mock provides these additional built-in attributes for verifying how it was called. The assert has calls function passes if the mock was called with the parameters specified in each of the passed-in list of mock call objects, and optionally in the order that those calls are put in the array. The called attribute is a boolean which is true if the mock was ever called. The call count attribute is an integer value specifying the number of times the mock object was called. The call args attribute contains the parameters that the mock was last called with. The call args list attribute is a list with each entry containing the parameters that were used in a call to the mock object. The unittest.mock also provides the Magicmock class. Magicmock is derived from mock and provides a default implementation of most of the Python magic methods. These are the methods with double underscores at the beginning and end of the name, like underscore underscore string underscore underscore and underscore underscore int underscore underscore. The following magic names are not supported by Magicmock due to being used by mock for other things or because mocking them could cause other issues: get attribute, set attribute, init, new, prepare, instance check, subclass check, and delete. I will use Magicmock by default in all of the examples in this course. I also use it by default in practice as it can simplify test setup. When using Magicmock, you just need to keep in mind the fact that the magic methods are already created and take note of the default values that return from those functions to ensure they match the needs of the test that's being implemented. PyTest provides the monkey patch test fixture to allow a test to dynamically change module and class attributes, dictionary entries, and environment variables. Unittest provides a patch decorator which performs similar operations, but this can sometimes conflict with the PyTest test fixtures decorators, so I'll focus on using monkey patch for this functionality.